Greetings, fellow Obsidizens of the vast Obsidian community. Welcome to another video in the Obsidian for Noobs video series, featuring tutorials, tips, and tools for new users of the Obsidian personal knowledge management software. In this video, I cover the fundamentals an Obsidian user needs to know in order to be able to use Obsidian's Bases core plugin. I begin with a brief discussion of the various components that make up a generic database, and then I show how those components relate specifically to Obsidian's Bases. I also explain the critically important role that YAML front matter properties play with regard to bases, and I provide a quick primer on YAML properties. Finally, I bring it all together by demonstrating a real case example that utilizes these concepts in an Obsidian Vault with a bases database. Please note that as of the time of this video's creation, which was August 2025, in order to be able to use Bases, you must be an Obsidian Catalyst member and install Early Access version 1.9.0 or above. Bases is enabled and disabled in the Core Plugins section of Obsidian settings. Okay, let's begin. In particular, this video will be divided into 6 parts as follows. I'll begin by describing and defining what a generic database is. Then I'll discuss what the components that make up a database are. Then we'll move into understanding how Obsidian's Bases functions as a database. I'll provide an introduction to Obsidian's YAML front matter properties. And then I'll use a real case example to demonstrate how to use Obsidian's Bases. Part 5 will include creating a database, table rows and columns, sorting, filtering, and views. And finally, I'll provide a review of all the important points discussed in the video. Part 1. What is a database? A database is a structured collection of information or data stored electronically in a computer system. The database's structure and operation provide a means of organizing the information so that users can quickly search, sort, and edit that information. Often, the most useful way to sort and view the data in a database is to present the data in table format with columns and rows, similar in appearance to a spreadsheet. Obsidian Bases uses tables to present a complete Vaults database, as well as the results of filtering and sorting performed on that database. Part 2. What are the components that make up a generic database? A generic database is composed of files, records, and fields. The best way to visualize a database structure is to consider a file cabinet filled with folders, where the folders contain a variety of documents, and those documents contain specific pieces of information. As you can see in the illustration, the file cabinet represents the complete database. That is, the complete collection of information. In Obsidian, this would be your vault. The files of a generic database correspond to folders in a computer database, and thus they correspond to the folders in your vault. The records of a database are the documents that make up your database. In the case of Obsidian, the records correspond to the notes in your vault. Finally, the fields in a generic database correspond to the individual pieces of information in the various documents. These might be a customer's name and address, or an employee's job title and tax status, or a student's completed courses and grades attained. In Obsidian, the fields correspond to a note's YAML front matter properties, which I will discuss in greater detail shortly. As an example, imagine a college in the pre-computer era maintaining a physical database of its active students. The database would be a file cabinet containing folders, one for each student. The folders might be arranged alphabetically by the students' last names. The records contained within each folder would be sheets of paper, such as, for example, a personal information sheet with the student's name, date of birth, home address, emergency contact, etc. Another record might be a student information sheet with the student's ID number, intended major, entrance exam scores, and so forth. Yet another record in the student's folder might be a course list of completed courses with the corresponding grades attained in each course. For example, Psychology 101, B+. Part 3. Understanding how Obsidian's Bases functions as a database. As I stated earlier, Obsidian presents its databases in a table format. Here you see an Obsidian Bases database table representing the staff and patients in a fictitious doctor's office. In any table of data, the rows and columns have critically important meanings with regard to the data in the table. In an Obsidian Bases table, the rows represent the notes in your vault, and the columns represent the YAML front matter properties in those notes. If you're unfamiliar with YAML front matter, don't worry, I'm going to cover that topic in detail shortly. So in this database, each row represents a record in the database, which are the notes of the vault. Each record consists of one or more fields. Fields correspond to the columns in the table and represent individual pieces of information in your notes, which, as I noted earlier, are represented by the YAML front matter properties of the notes. To keep this example simple, I've only included a few patients and a few staff members and a limited number of fields for each. Let me use this table now to demonstrate a few of the features of an Obsidian database base. First, I want to note that this is the entire database for the vault, and it contains every single file in that vault. Not only the notes, but all the files. So for example, you see here I have an assets folder, and in that assets folder I have 2 image files, 2 PNG files. They are both contained in the database. In a normal situation, you will usually want to work with only the notes of your vault. And I'll show you ways we can eliminate the extraneous files and limit the database table only to the notes. That's coming up soon. Also note, as I said a moment ago, that the rows are the files in your vault. You can see I have a folder with the patient's records, which are the notes, and I have a folder with the staff's records, which are also notes. And you can see the first column are the titles of those notes. So each row in the database table corresponds to a file or a note in your vault. Each column corresponds to a YAML front matter property in those notes. Let's look at one of those notes now. Here's a staff member named Betty Watson. These are the YAML front matter properties. I've created 4 properties for the staff members: job title, date hired, full or part-time, and the status. Again, in a real-world case, there would be many more properties, but to keep it simple, I'm limiting it to 4. Again, make note of the properties: job title, date hired, full or part-time, and status. If I go back to the database, you can see those are the column headings: job title, full or part-time, date hired, and status. The column headings in a database bases table correspond to the YAML front matter properties in your notes. The 2 most common operations performed on a basis table are sorting and filtering. Let me do a quick demo of those now, and then later on I'll introduce a more complex, sophisticated database, and I'll illustrate all of these operations and properties in greater detail. But just to give you a sense of what's happening here, let's start with a sort. Look at the status column. Some people are staff members, some people are patients. Again, these other files have nothing to do with the doctor's office. This is the actual database. This is a file I put in here. These are the picture files and so forth. If I want to group like records together, I can sort this database by the status column simply by clicking on that column. And now the records are grouped by the status property. You can see all the patients are together, all the staff members are together, and then all the extraneous files appear at the bottom. This would be a handy way to distinguish the patients from the staff very quickly. Simply click on the column heading and you will sort your database in accordance with that property represented by that column. On the first click, it sorts them alphabetically. If I click it again, it will sort them in reverse alphabetical order. So we should see the staff members at the top and then the patients. And that's exactly what happens. If I click one more time, it reverts back to the original database presentation, where the database is arranged alphabetically by the records. You can see it begins with A, Anna, and ends with S, staff. So again, to sort a database, pick a property that you want to sort by, click on the column heading for that property, and the database is sorted in accordance with that property. In this case, all records with status equal to patient appear together, all records with status equal to staff appear together, and any extraneous records appear on the bottom. If you click again, you get it in reverse alphabetical order. Click one more time, and it reverts back to the original format. Likewise, over here in this column, we have whether the staff employees are full-time or part-time. If I want to see them grouped together, I simply click on that. Here are all the full-time employees. Here are the part-time employees. Click again, reverse alphabetical order. One more click, original format. Imagine a company that has hundreds or thousands of employees, or a doctor that has hundreds of patients. Being able to sort the records this way is very convenient, very efficient. Let's look at date hired. This is for the staff members only. If the doctor wants to determine which employees have been with him the longest, simply click that column heading and you get the hiring dates in order. James Wright was the first one hired in April of 2010, then Lizette Sanchez, and so forth and so on. If I click it again, I'll get it in reverse. Now we know the newest member is Betty Watson. One more click, back to the original format. Now let's look at filtering. Filtering a database restricts the database to particular records that possess a particular property. For example, if I wanted to only see the records of the staff members from this database, I would click on Filter in the upper right corner, and I have a little filter formula box here. That filter formula involves three parts: a property, an operator, and a value. And I'll demonstrate that now. So we want to isolate only the staff members from this database. We isolate by property. Remember, the properties are the column headings. Whether an individual is a staff member or a patient is indicated by this status. So I click on property, and all the properties that are available are listed here. Some of these are built into Obsidian, and some are the ones that I have created. So I find status, I select that. In this case, I want the operator is. There are many different operators available. I'll discuss some of the others later when we work on the more sophisticated database. But for now, I just want to give you a taste of this. So I'm going to stay with is, and the status we're interested in is staff. So when I click on the value section, I get two choices because there are only two values used for status at this point, patient or staff. I select staff, and the database immediately limits itself to only the records that have the status equal to staff. That's what's happening with this filter formula here. I indicate a property, an operator, and a value. And I'm telling the database, only show me the records that satisfy this formula. In other words, in this case, only show me the records in which the status is staff. And you can see that's exactly what I have. If I wanted to see the patients, I could take staff out of there and select patient as the value. And then I get only the patients. So again, filtering restricts a database to particular records that satisfy a particular property. In this case, the one showing now, the property where the status is patient. To delete a filter, simply click on the trash can icon all the way at the right of the filter formula. And the database reverts back to its original format. In other words, the full, complete database. Let's do another filter. Let's see which employees are part-time. That's the full part-time column. That's the property I'm interested in. So when I click in property, I'm looking for full/part-time. Here it is. I want is again. And now I'm interested in a value of part. And it gives me only the records for which the full part-time property is equal to part. If I wanted the full-time employees, instead of part, I select full. I'll delete that filter. I think you can see with this simple example the tremendous power that filters have. You can take a huge database and restrict it to a grouping of records that satisfy a particular condition or a particular property. Again, I'll go into this in greater detail, and I'll demonstrate it with a more realistic situation later in the video. The true power of bases resides in their ability to filter the database records according to specific criteria chosen by you, and those criteria are defined by the YAML front matter properties which you have placed in your notes. As you saw in the demonstration I just did, we filtered our database records by selecting a property, an operator, and a value. Let's take a closer look at that. This is what's happening when we filter a database. We select a property, we select an operator, and we select a value. And what we're telling the database is, show me only the records for which this property is equal to this value. Now, as I said, there are other operators possible, and I'll show you several of them as we go on with further examples. But this gives you the general idea. The operator establishes a relationship between the property and a value. And once you define that relationship and you specify the property and the value, the database will limit the records it displays to only those records that satisfy the relationship you've indicated here. I think it's obvious from these limited examples that YAML properties play a critical role in Obsidian Bases. Specifically, all sorting and filtering in an Obsidian base is accomplished by referencing YAML properties. It thus behooves us to discuss the topic of YAML front matter properties in greater detail. And I'll do that now. Part 4, a brief overview of Obsidian YAML front matter properties. What is YAML? Obsidian's YAML front matter is a block of metadata written in YAML format and placed at the very beginning of a node. Metadata is simply data about data. In other words, it is data that identifies or describes other data. For example, the metadata for a digital photo might be the date, time, and place the photo was taken. The important data is the photo. Its metadata provides identifying information about the photo. In Obsidian, the content of your notes is the important data, but you can use YAML properties to provide identifying data about the notes. YAML provides a structured, organized, consistent format for storing descriptive information about notes. To open the YAML properties section of a note, we type 3 hyphens just below the note's title. That will immediately open the YAML section. Let me demonstrate that now. Okay, I'm back in the mock doctor's office vault, and let me create a new note. I'll leave it untitled. I'm dropping to the line directly below the title, and I'm going to type 3 hyphens. And immediately the YAML front matter properties open. I can select a property from the ones listed here. The first 4 are default properties that are automatically provided by Obsidian. The rest are properties that I've created. So you can create your own properties simply by typing it here. That's how you create a property. So if we imagine that instead of this being a doctor's office vault, this was a vault for my book collection, and I was making notes for each of my books, I might want a property called title. Over here is a value that's assigned to that property. One book I might have might be Moby Dick, the famous Herman Melville novel. And now I've created metadata for this note. The note itself might contain a summary of the novel Moby Dick. It might contain a list of the characters. It might contain my reactions and comments about the book, and so forth. But I have identifying information about the note contained in the YAML properties. If I wanted to add more properties, I simply click on Add Property and go through the same process. I create a property by giving it a name, and then I assign a value for that property here. The icon to the left of the property name represents the property type. And there are 6 different property types available in Obsidian. If I left-click on that icon and then hover over property type, you see the 6 property types here. The type determines what kind of values the property can store and how Obsidian handles them. A property's type is identified by the icon that appears to the left of the property's name. The type can be changed by clicking on this icon. Let me provide a brief description of each property type now. The default property type is text, and that means the value you're going to assign to any properties of that type will be text. That's probably the most commonly used one. The number property refers to literal numbers. In other words, not phone numbers or dates, but numbers that you might perform arithmetic on. And for the number type, both integers and decimals are allowed. The list type is used very often because the list type allows you to assign more than one value to a property. Let me create a new property called characters. If I'm going to list the characters over here, there are going to be more than one, obviously. So the text property will not, so the text type will not work here because that allows me to only enter one value. That allows me to only assign one value to this property. Instead, I'm going to change the type to list. Now I can assign several values to this property. So for example, one character was Captain Ahab. I type that value, and since it's a list, I can enter more. What I do is I press the Enter key when I'm finished. The little X allows me to delete this value if I want to, and the cursor moves over to be ready to accept another value. Starbuck was another character in this book, I believe. And so forth and so on. So the list property is very handy. It's often used when you anticipate the possibility of assigning more than one value to a particular property. Going back to the various type options. Date and time follow your operating system's default date and time format. If I add another property here, I'll call it X, and I make it of type date. You can see I get month, day, year. And if I click on the calendar, I can select the date from here, or I can type it in manually. The checkbox type refer to either situations that are either true or false. If the property is left empty, it's treated as false. In live preview, it's represented by a checkbox. So if you check it, you're saying it's true. If you leave it unchecked, you're saying it's false. So again, the various types for properties are text, just anything that involves text, literal numbers. The list property allows you to assign more than one value to a property. Date and time and date, use your operating system's default date and time settings. And checkbox is used for situations that are either true or false. Another important note about YAML front matter properties is that links are permitted in both the text and the list types. Let's do that. I'm creating a new property, and I'm going to make it link to Betty Watson. So I'll call it Betty W. And for the value, I'm going to create a link. And we create links in YAML the same way we do in Notes. We begin by typing 2 open brackets, and I get a list of all the files in this vault. And I'm looking for Betty Watson. There she is. And I have a link to Betty Watson. If I click it, I go to Betty Watson's record, which is the note with all her YAML properties. And I can go back. A small point about these links. If you go into source mode, you're going to see quotes around the brackets, right? Right now, there are no quotes, but if I activate source mode, you can see the quotes there. Also notice that in a list type property, the individual items are preceded by a hyphen. Okay, let's get out of source mode. So as you just saw, Each piece of metadata in the YAML front matter properties is represented by a type, a property name, and a property value, as indicated here. The type icon identifies the type, and it appears first to the left of the property name. Then you have the property name. It can be one of the default built-in properties in Obsidian, or it can be any property that you create. You simply type the name you want here, and you've created a property. And then you assign a value to that property. If the property type is list, you have the option of assigning several values if need be. Please note that once a property type is assigned to a property name, all properties with that name across your entire vault will use the same type. As we saw earlier when I did the quick demo of an Obsidian Bases database table, Obsidian's Bases uses YAML Properties to sort and filter the database table it creates. This is why understanding YAML Properties is so crucial to understanding and using Obsidian's Bases. Remember, in an Obsidian Bases database table, each row corresponds to a note in your vault. That's a record of the database. And each column corresponds to a particular YAML front matter property. These are the fields of the database. Now, having discussed YAML front matter properties, we can bring everything we learned about databases and YAML together to see exactly how Obsidian Bases work. In Part 5, I'm going to now use a real case example to demonstrate how to use Obsidian Bases, including how to create a database, how table rows and columns are used, how to sort, how to filter, and the topic of views. In order to demonstrate how Obsidian Bases work, I've created another vault that contains fictitious records of a medical doctor's patients. I've picked the YAML properties for each record by anticipating a variety of ways a doctor's office might need to filter or sort its patients. Let's take a look at this vault and see how Obsidian Bases works. Okay, this is a different sample vault from the one I used earlier. It's a little bit more complex, a little bit more realistic. This is strictly a record of fictitious patients for a doctor's office. Here's one particular patient. These are the YAML properties. And I've done this for every patient. In fact, when you're going to work with a Bases database in an Obsidian Vault, it's a good idea to start by creating a template for the records you're going to use in the database. This is the template I created for the patients. They're all YAML front matter properties. Date of birth, I gave that the date type. Medical conditions, in other words, the illnesses, I gave that the list type because a patient can have more than one illness. The prescription drugs the patient takes, again, I gave that a list type because there may be more than one drug taken. The health insurance that the patient has, again, a list type because some patients have more than one health insurance. For example, they might be Medicare primary and have their own secondary insurance. Emergency contact name, that's simple text. Emergency contact phone number, again, simple text. Emergency contact relationship, text. The patient's home phone, the patient's work phone. Obviously, a doctor's database of patients would have even more information. I didn't want to make it too complicated, so I limited it to these particular properties. So again, going to a particular patient's record now. Here's Anna Star, and you can see the values have been assigned to the properties. I could have made a property for the patient's name, but I decided to use the note's title as the patient's name. And that is always the first column in the Bases database. Notice that for Anna Star's medical condition, she has 2. That's why I made that of list type. Same for prescription drugs. She's taking 2 different drugs. That's a list. In order to create a database, the easiest way is to bring up the command palette, Control-P, and look for Bases, Create New Base, and click that. You will immediately get a database table of every single file in your vault. Again, not only the notes, but all files. I have an image file here, my template file shows up here, and some databases that I already created. And I'll show you how to limit this in a moment. Now, the only thing you get is a listing of all the files in the vault. Obviously, it's useless in this format. What we need are the columns. which correspond to the properties in the YAML front matter. So I want all these properties as columns in my base. The way we add columns to a database table is by clicking on properties in the upper right corner here. When I click there, I'll get a list of pre-existing default properties that are automatically included with Obsidian, and then at the bottom, any properties I've created. And I'm going to select all of those properties now. Notice when I select a property here, it appears as a column in the database table. There's date of birth, emergency contact name, so forth and so on. And now I have all of the columns representing the various properties in my patient records. To widen a column, just drag. To move a column, left click on the column heading, hold the mouse button in, and drag to the desired location. You can see if the database is too wide to fit on the screen. You can drag this little slider bar at the bottom and go over to the side and see the remaining columns. I want to bring the prescription drugs and the medical conditions over to the left where we can see them, because I'm going to use them for doing some filtering later. Let's begin by doing some sorting. One of the properties that the patient's records have is their health insurance. Now again, as I pointed out with the earlier example I did, the database lists all the files in your vault according to the note titles, and it does it alphabetically in the first column. So you can see we're starting with A, Anna, all the way down to W for Walter Harrington. Therefore, all the various properties are going to be all mixed up. If the doctor wants to group together all the different health insurances, he can simply click on the column heading to sort the database by this property. So I'm going to click on health insurance, and now they're all grouped together, as we saw in the previous example with the doctor's staff. All patients who have Axel health insurance are here, all who have HealthWise are here, and people who have Medicare and something else are here. Remember, the first click on the column heading sorts it alphabetically. Second click, reverse alphabetically, so we can see this in the opposite order, which we do. And the third click brings it back to its original format. Let's do some filtering now. Remember, to filter, click in the upper right corner on Filter, and you get the filter formula box. Remember, we need a property, an operator, and a value. Let's say we want to see all patients that have high blood pressure. That's a medical condition. HBP represents high blood pressure. But notice that some people have that in addition to other illnesses. So the property I want is the column heading, medical condition. And I scroll down until I find that. I select that. Now we do not want is exactly, because as I just pointed out, there may be other conditions as well. We want to use the operator contains. That has a broader scope. Now I'm saying list all records where the medical condition contains HBP. And I get only those patients that have high blood pressure. If I made the operator is, I'm now saying I only want records that have only HBP. And when I click that, you'll see we have nothing. It's empty. So you have to be very careful how you select your operator. In this case, I want a broader scope. I want all patients whose medical condition includes or contains high blood pressure. All right, let me delete this filter. We'll go back to the original database. By the way, to get rid of this little window, just click off to the side anywheres. All right, let's say now we want to see all patients who take the drug levothyroxine. So I click on filter in the upper right corner. Now, the property I'm interested in is prescription drugs. Remember, the column heading represents the YAML properties in the records. So the property is prescription drugs. There it is. Again, I want to do contains because it's possible that there are more than one drug there. So I want a broader scope. And the drug we're interested in is levothyroxine. And I get all the patients now that have the drug levothyroxine. If I said in the filter is instead of contains as the operator, I would only have this first patient, Dennis Glenn, because that guy is taking strictly levothyroxine. Let's look at that. Let's delete the filter. Let me do the same one. Prescription drug. Now I'll do is exactly, and we'll do levothyroxine. And we get only Dennis Glenn because he's taking exactly only levothyroxine. But if we want everybody who's taking that, we broaden the scope of the operator by choosing contains. And then we get everyone who takes it. In this case, these two people. I'll delete that filter. Let's say now the doctor wants a list of all patients who are on Medicare. That's under health insurance. So that's the property I'm going to filter by. And the value I'm interested in is Medicare. And again, we can have Medicare with other health insurances. So I'm going to want to use the operator contains. I want the broader scope here. So filter, property is health insurance. I want contains, and I want Medicare. Every patient who's on Medicare is shown. Again, imagine a database with many records, right? A doctor or a hospital, let's say, that has hundreds of patients, and they need to isolate the patients who are on Medicare for some reason. They can do it very quickly by performing a filter. I'll delete that filter. It's possible to have more than one filter applied to the database together. Let's do an example of that now. Let's say the doctor's interested in finding all patients who have Medicare as their primary insurance and Axle as their secondary insurance. If you look down the health insurance column here, we have Jane Williams and we have Paula Miller. So we'll do two filters. First, property is health insurance. We want contains because we want the broad scope, and we want to isolate all the Medicare people. 4 patients have Medicare. Now, we'll add a filter. I'm clicking on Add Filter here. And again, for the property, I want health insurance, and I want contains for the operator. And now I want Axle. And it gives me only the patients that have both Medicare and Axle. Let's delete that and do another example. Let's say now, we want all patients who have HealthWise insurance and who have a urinary tract infection, which is UTI. So first, property is health insurance, contains HealthWise. Second filter, the property is medical condition, contains urinary tract infection, UTI. And these are all the patients that have the HealthWise insurance and this condition. We can imagine a situation, theoretically, where the doctor receives notification that this particular insurance is no longer going to cover treatment for urinary tract infections, and the doctor wants to inform his patients of that. So he consults his database of his patients, isolates the patients that have both health-wise insurance and urinary tract infections, so he can contact them or have his staff contact them and inform them of this change. Okay, another important point here. You can edit information in these records directly in the database. You naturally can do it in a patient's note record. For example, if Mary Jones gets a new medical condition, let's say GERD, gastroesophageal reflux disease, I could add it here in her patient record, in the note that corresponds to her patient record. Right? She originally had 3, and I'm adding GERD. If we go to the database, we see now that Mary Jones has this 4th medical condition, GERD. But I can also make edits in the database itself. So if Kelly Donovan unfortunately acquires asthma, I can add it here in the database. And I will see in Kelly Donovan's record that asthma is now there. Right? It wasn't there originally, but it's there now. So if you perform an edit in the YAML properties in the note, which is the record for the patient, or whatever your database represents, then that change you made in the note will appear in the database automatically. Likewise, if you make an edit in the database, that change will appear in the corresponding note record. Let's add a new record. I'll create a note. I'll give it a person's name. Tom Thumb. And I'm going to call up the command palette with Control P. And I'm going to put Insert Template. I'm going to select Insert Template. I only have one template in this vault. It's the patient template. And I'm ready to create a brand new patient record. I'll give this guy a birth date. We'll give him a medical condition. Now notice all the existing conditions appear, so I can just select one from the list. But I can also introduce a new condition here if I want. I'm not limited to these. So let's say that Tom Thumb has angina. I don't know what drug is taken for angina, so I'm not going to guess. Health insurance, let's say he has HealthWise. And I won't fill in the rest of these. I'll put this in the patients folder. Now, by me creating this record with these YAML properties, this individual will automatically appear in our database. If we look down the list, here's Tom Thumb with the date of birth I gave him, HealthWise insurance, angina as his medical condition. So that's how you can add a record to your database. Simply create a note, put in the YAML properties, and it will automatically appear in your database. Okay, I pointed out earlier that when you create a bases database in a vault, every single file in the vault appears in the database. And you may not want that. Okay, here I have a PNG image that's in my assets folder, has nothing to do with this database. The patient template is here. I really don't want that in the database, and any databases I created are here as well. By the way, notice that databases in Obsidian have an extension .basc. I want to limit this database solely to the notes in my vault. I can do that with a filter as follows. I click on Filter in the upper right corner, and for property, instead of picking one of the properties I created, I'm going to pick one of the pre-existing properties provided by Obsidian. In this case, file extension. And I'm going to leave the operator as is because I want an exact match here. And for the value, I'm going to put MD. MD stands for Markdown, and that's the file extension that Obsidian puts on all of its notes. If you were to open File Explorer in Windows and go to the folder for your vault, you will see that all the notes have a file extension MD. So what I'm telling Obsidian here is that I want it to only display the records that have a file extension that is equal to MD. And when I hit enter, you'll see that the PNG file and the databases and the template disappear, and my base table will then only show me the notes in the vault. There it is. All those extraneous files are gone. These are strictly the notes in the vault, which in this case are the patients for the doctor. Let me delete that and demonstrate another filter. Another way I could have accomplished the same thing is, since I've put all of my patients in a folder called Patients, I can do a filter by that folder. My property now is folder. Operator is, and it gives me a list of all the folders in my vault, and I select Patients. What I'm telling it now is, limit the display of the database table to only files in the Patients folder. And once again, I have only the files I'm interested in. I should say only the records I'm interested in, which are the notes that correspond to the patient records. I want to cover something called views. Obsidian lets you retain particular filterings of your database. If you filter the records of the database in a particular way, and you anticipate you may want to use that view of the database, in other words, that limited presentation of the files in the database, that limited presentation of the records in the database, you can preserve that filtering by using a view. And I'll do that now. Let's say the doctor wants to keep a presentation of this database table that shows only her patients that have the health insurance Medicare. What I can do is up here where it says table, I'm going to click, and I'm going to then click Add View. I give the view a name. I'll call it Medicare Patients. Once I've given it a name, above it I click on Configure View, and now I'm going to set up how I want that view to look. So I get the raw database. I'll start with the filter. I want only patients whose health insurance contains Medicare. Now I also want to see all the properties, so I open up Properties and I select all the properties that apply to my patients. If I only wanted some properties, I would just click those. I can move the columns around if I want. And now what I've done, I've created a permanent view, which is this limited database table. So if I go back to Table, I'll get the original full database of the entire vault with the filter limited to the folder of patients. But if the doctor quickly needs to see her Medicare patients, instead of conducting a filter or a sort, she can simply select the Medicare patients view. Again, what views do is preserve a particular sorting or filtering of your database. Let's do another one. Let's say the doctor wants to keep a permanent database presentation of all her patients that have a high blood pressure. So I'm going to add a view. I'm going to give it a name. I'm going to call it HBP, high blood pressure patients. and I click on Configure View. I start with a filter. In this case, it's medical condition contains HBP. I add whatever properties I want. And I've preserved this view. I'll go back to the main database. If the doctor wants to quickly see which patients have high blood pressure, let's say she found out about a new medication that treats high blood pressure and it's better than the one she had been prescribing, and she wants to quickly contact all these patients to let them know that she's going to change the prescription of the drug she's giving them, rather than sorting or filtering the whole patient database, she can simply call up her HBP patients view and immediately see all the patients that have high blood pressure. So that's views. Okay, we've covered a lot in this video, but it's important stuff, and I think it's worth taking the time to review the most important points that were covered. Let me run through them now. First of all, an Obsidian base is a database of all the files in a vault, and it's presented in table format. As we saw, each row in the table corresponds to a file in your vault, which is a record of a database. Each column of the table corresponds to a YAML front matter property in your notes. To create a new base, select Bases, Create New Base from the command palette. To add columns to the table, click on the properties in the upper right corner and select the desired properties that you want displayed in the table. And remember, the properties that are presented are the YAML front matter properties from your notes. You create the YAML front matter properties yourself, right? When you create the template for the notes, what you should do is anticipate what things you might want to search or filter or sort your database by, and then select your YAML front matter properties accordingly. But don't forget, you can add properties at any time. I did that in a couple of the examples. So you're not stuck with the original layout that you create. At any time you want, you can add values and properties to your database, to your notes. But the more you anticipate what you will need up front at the beginning, the easier it's going to be. So again, you decide on what YAML front matter properties you want in your notes. And you should think that through before you begin worrying about a database. You can reposition a column in the database by clicking on its heading and dragging it to the desired location. You can sort the table by clicking on the heading of any column. Remember, you're sorting by properties there. You filter the table by clicking on Filter in the upper right corner and then selecting a property, an operator, and a value. And remember, it's possible to have more than one filter. Finally, you can use views to preserve a filtered table. To create a view, you click in the upper left corner, select Add View, give the view a name, then click on Configure View. It will give you the full database. Apply whatever filters you want to apply, add whatever properties, in other words, columns to the table that you want, and then you have preserved that view. Whenever you want to see that view, you just click in the upper left corner and select it from the list. Finally, the four most important takeaways from this entire lesson, I think, are the following. First, decide on your YAML properties by anticipating how you might want to filter your database. Create a template once you have decided on the YAML properties that you will put in your notes. And remember, the rows in your database table are the files and notes in your vault, and the columns in your database table are the YAML front matter properties that you created in your notes. So there you have it, the basics of using bases in Obsidian. If you're using Obsidian primarily for simple note-taking, then bases is probably unnecessary overkill. But if you're using Obsidian as an information management system, then Bases offers a vast degree of power for sorting, organizing, and filtering your data. There's a lot more to Bases than I presented here, and a lot more to YAML as well. But I hope that I've given you enough basic information about both YAML and Bases to allow you to begin incorporating Bases into your Obsidian vaults easily and productively. Okay, fellow Obsidizens, that's all I have for now. I'll see you in the next video. Happy note-taking.